Lesson 14 is going to be on limiting reagents in chemical equations. This is an SAT 2 topic. So we're going to be talking about the different steps for determining your limiting reagent, and we're going to do a practice problem. The limiting reactant, otherwise called the limiting reagent, is the reactant that is not present in excess. The question will always state to you that you have a certain amount of this, and something else is in excess. The reactant that is completely consumed in the reactions is called your limiting reactant. It will always be used 100%. The excess reactant is the reactant or reactants present in excess. This means that you have an unknown amount, but it's enough that you can do any reaction with it. The reactant that will remain partially unused at the end of the reaction. So limiting is the thing that is in a small amount, while excess is the thing that you more or less have unlimited amounts of. Whenever your limiting reactant has been completely consumed, your chemical reaction will stop. For example, think of fire. Fire, when you are watching it, in excess is oxygen. It's all around us. It always feeds the fire. But your limiting reactant, like wood or a piece of paper, once you have used up all the piece of paper or all that wood, the reaction will stop. So there's going to be a couple steps to determining these questions. So the first thing you have to do is calculate the mole ratio of the reactants in the problem from the measured quantities provided in the problem. This means, for example, if they say that you have 80 grams of nitrogen gas and excess of oxygen. So that's going to be your mole ratio. The second step is you have to calculate again another mole ratio, but now you're looking at the balanced equation using the coefficients. Again, go back to lesson 11 to think about what are mole ratios. The third step is going to be the complex step. You have to now compare the mole ratios. If the mole ratio of the measured quantity is larger than the mole ratio of the balanced equation, then the quantity in the numerator, the top of the fraction of the mole equation, is what we call the excess reactant. If the mole ratio of the measured quantities is lower than the mole ratio of the balanced equation, the quantity in the numerator, that again, top of the fraction, of the mole equation is your limiting reactant. So all we're doing is making ratios and comparing them to each other to see which one is larger or smaller. In step 4, the amount of excess reactant consumed in the reaction can be calculated using the measured numbers of moles of the limiting reactant and the molar mass of the reactants as a conversion factor. So the new amount of moles times the limiting mole ratio is equal to the amount of moles consumed. So let's go back to that Haber-Bosch process where you take nitrogen and hydrogen to make ammonia. In this situation, you have 2 moles of nitrogen gas is combined with 2 moles of hydrogen gas. Which of the 2 reactants is limiting? Which of the 2 reactants is the one that causes your reaction to cease because you physically run out of it? Determine how much was used in this reaction. So remember, step 1 is to compare the mole ratio of the stuff in the question. So from your reading, you get 2 moles of nitrogen over 2 moles of hydrogen. Well, 2 divided by 2 gives you an answer that is 1. Okay, that's step 1. Now we have to look at step 2, which is from the actual balanced equation, comparing nitrogen on top to hydrogen on the bottom. Here we have a 1:3 ratio. It is a smaller ratio than step 1. So right off the bat, we're noticing that we have different numbers, and let's go to step 3. Step 3 is using our mole ratios. So again, this is just a repeat. If the mole ratio of the measured quantities is larger than the mole ratio of the balanced, then the quantity in the numerator is the thing in excess. If the mole ratio of the measured quantities is lower than the balanced equation, then that means your numerator, again, top of the fraction, is going to be your limiting reactant. So using that information, we can determine that nitrogen is going to be in excess, while hydrogen is going to be limiting. If you think about it, looking at your balanced equation, 1 mole of nitrogen is equal to 3 moles of hydrogen. So now if you have 2 moles of nitrogen, you technically need to have 6 moles of hydrogen if you were to do this reaction to completion. So in this situation, if you're just looking at what you have in your balanced and what you have given to you in the question, you can also kind of guess which one's going to be limiting as well. So step 4, which is finding the amount unused, is very simple to do. The first thing you do is you take your limiting reagent. We know that's 2 moles of hydrogen gas because this comes directly from the question. 2 moles of hydrogen gas is now being multiplied by the lesser mole ratio. So what is 2 times 0.3? You're going to get 0.61 moles of nitrogen consumed. If you think about it, 1 mole of nitrogen has to be used if you're going to be making ammonia. You also need 3 moles of hydrogen. So in this situation, we don't have 3 moles of hydrogen, we have 2. So proportionately, you can only use less than 1 mole of nitrogen. So if you then take your 2 moles to begin with, and you subtract it from how much you consumed, you can figure out in any problem using these 3 steps, you can always figure out how much is never consumed. In this situation, 1.33 moles of nitrogen gas was not consumed in the reaction and is still floating around whatever chamber this chemical reaction is occurring in. Let's try this one. Given the balanced equation below, which reactant is in excess if you have 10 moles of CuCl2 and 5 moles of AgNO3, and they are added to the reaction vessel? As well, how much of the excess reactant remains unused? So again, step 1 is look in the question itself. I'm seeing that I have 10 moles of copper chloride and 5 moles of silver nitrate. So 10 over 5 tells me I have a mole ratio of 2. So this is from my reading. Now let's look at my balanced formula. Here I have 1 mole of copper chloride over 2 moles of silver nitrate. This is going to be a much smaller number, which is 0.5. Therefore, with great certainty, I can conclude that the copper chloride is in excess, while the silver nitrate is limiting. Again, look at the question. In the balanced equation, 1 mole of copper chloride is needed to react with 2 moles of silver nitrate. So therefore, if you have 10 moles of copper chloride, you would have to have 20 moles of silver nitrate to go to completion. In this case, we only have 5. This makes it limiting. Step 4 is to again take the limiting reagent, which is our 5 moles of silver nitrate. We're multiplying it by the limiting ratio, which is 0.5 if you think about that mathematically. So 5 times 0.5 tells us that we have about 2.5 moles of copper chloride being consumed. If we start with 10 moles and we use 2.5 moles, subtracting to find the difference, you get about 7.5 moles of copper chloride that was not consumed in this reaction. Again, the copper chloride would just be floating around the reaction vessel, not reacting with any of the products that were created.